Fuse means it's a wire. The resistance of all bulbs are identical. Let this be 8 volt. All bulbs are identical, and the resistance of it and the resistance of them be 25 ohm. The maximum current through a fuse is 13 ampere. How many bulbs we can connect? So what is the maximum possible current permitted across the fuse? It is 13 ampere. And what is the EMF of the source? 8 volt. And the resistance of each bulb is how much? All bulbs are identical. The resistance of them is 25. How many bulbs we can connect like this?
Huh?
No. Yeah, like this. Huh? How many bulbs we can connect before the fuse blows? What is the fuse? It's a wire. Huh? Just it's a copper wire. So what it does, there's some maximum permitted current. If the current becomes more than the maximum value, so it will burn out. The E generated will be such that it will burn out and will become open circuit. Fuse is a wire. It's a wire. This is a fuse. It's a wire where some maximum current is prescribed 40. For the day. Yeah, okay, I'll check it now. Now, what is the fuse? Fuse a wire, that one. If any current greater than, if current through a fuse is more than maximum permitted current, the fuse will burn out. Burn out means what will become? It will become open circuit. So I'll put a condition. What is that? When current through a fuse. Fuse means it's a wire. When current through a fuse is greater than IM, the fuse will burn and becomes open circuit. So in house what happen, all the connections are done parallel, and we say loading problem, no? So the technical words we use like this, overload, that's why the fuse got burnt. So that only is what I'm discussing now. So let's do one thing. We'll calculate current, nothing big, we'll calculate current. So current through them will be same, no? Current through each bulb should be same. So the total current through the fuse. So let me write IM. So what is IM? IM should be equal to NI. What is I? I should be equal to, it's connected parallel across a cell. So what is I is equal to? I is equal to, you're going to write it as E by R. What is E? 8 volt. This is 25. So what is value of let me write it. So IM is given how much? 13. N, this will be 8 by 25. So N equal to 13 into 25 by 8. Anybody value?
40.62.
40.625.
40.62. So what shall I put in? 40 only. 0.62 bulb will not come. And if you put 41, the fuse will burn out. So 40, it's safe. So like that, we can connect 40 bulbs as will be safe. Sir, what if I connect 20 bulbs? No problem. The fuse, the current through the fuse will be less than IM. The fuse will not burn out. I think this is a very good way of dealing with this one. Now you can ask question like, what is a fun year selecting? Okay, you studied everything fine. It will current more than that will burn out. Okay, don't look at the fuse. Huh? Let's look at these wires. These wires are very important. These are like electrical wirings, no, which we'll use to connect the different equipments. Now, those wirings, are there any upper limit of current? Yes. So if you look at the slots, no, these are the slots. It will start with 2 ampere, 5 ampere, 10 ampere, 20 ampere, 50 ampere. It all depends upon the application. 2 ampere is what the normal slots, what we use for mobile charging, everything. 5 ampere what will come for the mixer, the refrigerator. The 15 or 10 or 20 ampere, we use this for the air conditioners, the electrical heater, the engine, the water pump, all the. This is for higher industrial applications. Then to what happen for the fridge, okay, for the refrigerator, fan, tube light, what happen, we need 2 ampere. So the wiring should be 2 ampere wire. I'll be using 2 ampere wire. That one. Then for all the electrical heater, that one. Then air conditioner. So I'll go for 5 ampere one. The mixer, everything. Then 10 ampere for the higher applications where they need more power. So like that, in ohm, what happen? We'll be doing wiring for 3 types of the currents flowing. Okay, this depending upon the equipment, the current has to be supplied. So for that, the wiring has to be done separately. Okay, clear this? So now, here what will happen? These wires are problem. If the current through a wire is more than the permitted current, the wire will burn out. I think you've seen the ohm. If the wire burns out, it's a big problem. No, you have to open the board, switch board, then you have to pull the wires. That one. So how to protect all these wires? The wiring in an ohm or in an equipment, everything, that one. The fuse is the best thing. So what should be the fuse? How I should calculate? I look at all the wirings which I do. 2 ampere, 5 ampere, 10 ampere. Then how many circuit boards are there, slots, what happen? Keeping that, what happen? I'll pick up a copper wire, I'll connect it. So the fuse becomes what happens. Suppose if any excess current comes, what will happen? The first fuse will burn out. If fuse burn out, it will become open circuit. Then you protect all the equipments. So what is the fuse? How much it will cost you? Around, I think, 120 rupees. So sometimes when excess power comes, what happens? The eliminator will fall down, no? The particular thing will fall down. So it will fall down, then we'll go and open it again. So first what happen? Yeah, worst case what happen? The inside the wire in that fuse what happen will burn out here. Then it protect all that. If there's this fuse not there, tell me what will happen. If any excess current comes up, it will damage all the equipments, no? So what is the cost of fuse? Very less, no? Inside the fuse again, major element. If any excess current comes, the wire will burn out. So altogether we are safe, no? Okay, so just a small basic idea.